Here we go with our SPSS file to conduct the independent samples tree test. Let us look at the variable view to understand what the variables. So the first variable is a respondent ID or a respondent number, which would have been allotted to each respondent so that the respondents can be identified. Then the second variable is company. So look at the values. There are two companies, company 1 quoted as 1 and company 2 quoted as 2. And we have a scale variable here, which is motivation. So this is a study of motivation scores in two companies. And our hypothesis is to test whether these motivation scores are significantly different from one another. So the null hypothesis is that the motivation score in population 1, that is company 1 here, will be equal to the motivation score in population 2, that is company 2. So null is mu1 is equal to mu2, and the alternative is that mu1 is not equal to mu2. So here we go to do the independent samples tree test. The idea is that these samples have been drawn independently. So go to analyze, then compare means, go to independent samples tree test, and here are our variables on the left side box. So we'll take the motivation into the test variable box, and we'll take company into the grouping variable. So then once we have taken this into grouping variable, we have to define the groups. So click on define groups, and group 1 is coded as 1 and group 2 is coded as 2. That's what we have seen in the variable view just before we came here to analyze this. So click continue, and let's look at options. The confidence interval percentage, leave it at 95%. So click continue and then click OK. So the SPSS throws this output. So let us look at the descriptives. So we understand that there are 81 respondents from company 1 and 94 respondents from company 2. So these are the mean scores of motivation. From company 1 4.25 and company 2 3.71. The standard deviation is given here, and of course the standard error of the mean. Now we look into the main table of the output. Once we go here, we need to test for one more assumption of the independent samples t test, that equality of variances. So the independent samples t test assumes that the variances of the two populations are approximately equal. That's what we see here as looking at the standard deviation figures, but of course we need to test whether there is a significant difference between these two variances or standard deviations. So we have a Levin's test of equality of variances, the results of which are presented here. So before interpreting the results of independent samples t test, we start with the interpretation of the test for equality of variances. So here the significance level thrown out is 0.795, which is way above our alpha, that is 0.05. So here the null hypothesis is that the variances of these two populations are equal, and alternative is they are not. As the p-value is higher than the alpha value, that is 0.05, we fail to reject H0 and conclude that the variances are approximately equal. So once we decide that variances are approximately equal, would be using this row of the table. That means this t value, this degrees of freedom, and this significance level. Once we have failed to reject this h naught, that the variances have been equal. And in case maybe in a different study, if the significant value of this test would have been less than 0.05, then we would have rejected this h naught, that the variances are equal, and we would have used the second row in that case. So now for our study, the relevant row is the first row, and then the t value is given here, the degrees of freedom given here. But as we have already noted, so our interest is just to go with the p value for the t test. So as the p value is 0.00 is less than or 0.05, we reject the null hypothesis that mu1 is equal to mu2, and conclude that uh, the two population means are significantly different.